In the 16th question, we have 1 upon x times x power n plus 1. And how do we solve this? So, this solution of this can be found with the simple idea, and there's a one particular hint also given over here. Multiply numerator and denominator by x power n minus 1 and put x power n equals to t. So that's something which you can do very easily, right? So let's use that idea. I is equal to integral of 1 upon x times x power n plus 1 dx. This is what you have, right or not? Yes. So what do? We can multiply with x power n minus 1 and put x power n equals to t. Yes. So let's do it. Integral will be x power n minus 1 upon x power n minus 1 times x will be x power n. This is x power n plus 1 already there. This is dx. Is that okay? Yes. And we can put x power n is equal to t, and that tells me that n x power n minus 1 times dx will be equal to dt. This is what you can note, right? This is x power n minus 1. Dx will be equal to dt, and x power n minus 1 dx will be equal to dt upon n. So therefore, I will be equal to integral of x power n minus 1 dx, which will be equal to 1 by n dt upon, this becomes t times t plus 1. This is what you get. Is that okay? Yes. And this can further be broken down into two partial fractions. I'll write those two partial fractions. What is that? What I'll get is 1 upon t minus 1 upon t plus 1. You can convert into partial fractions very easily. You know the approach, right? So this is t plus 1 minus t, which is 1 upon t times t plus 1 is what I'll get. Conversion into partial fractions, so it's not difficult, right? And the integral will be 1 by n log 1 by n actually, not 1 by 2. This is 1 by n. In the bracket, you'll have log modulus t minus log modulus t plus 1 plus constant. And what is that? 1 by n log modulus t over t plus 1 is what I get, plus constant. Is that okay? Yes. T can further be replaced with x power n over there. 1 by n is okay. This is log modulus x power n over x power n plus 1 plus constant, and that is the final answer for this particular question. But is this the only approach? No, there's one more approach. Let's take a look at another approach over here. Let's take a look at alternative approach over here. And what does that approach tell me? Okay, I want to integrate this 1 upon x times x power n plus 1 integral with respect to x. So one simple approach would be, can you take this x power n common from here? Okay, what do we want to do? So I want to take this x power n common from here, and what does that give me? This is dx, which is okay. X power n common will tell me, okay, this becomes x power n plus 1, and this here is 1 plus 1 upon x power n. This is what you get. Is that okay? Yes. There was a 1 over there, so taking x power n common will give me this particular form. Is that okay? Yes. And now I can use a simple substitution. Much simpler than this whole process will be to use the substitution. Let 1 plus 1 upon x power n, this complicated expression, equals t in the denominator, and what does that give me? So this 1 derivative 0, x power minus n, the derivative will be minus 1 n upon x power n plus 1 dx will be equal to dt. This is the substitution, and therefore I will now convert to what? I will convert to dx upon x power n plus 1. Do you observe that the derivative has been created? Over there, derivative is present. So dt upon minus n, or minus 1 by n integral dt upon, this goes 1 plus 1 upon x power n is this t over here. This is what you get, right? And yes, this is minus 1 by n log modulus t, yes, plus constant. That is my final answer, except for the fact that we have to substitute the value of t over here. This is minus 1 by n log modulus t. T is this 1 plus 1 upon x power n plus constant, and that is my required answer for this particular question. So answer has been found in two different ways, but the answer should be same, right? Let's take a look at this answer over here. This is equal to this. Is this also equal to this? Yes, this is x power n plus 1 upon x power n, right? Okay, you take a reciprocal, you get a minus outside, right? Log of 1 by x is minus log x, right? So x power n plus 1 will come in the denominator, x power n will go in the numerator, taking the reciprocal, and there will be extra minus which will be equal to this, right? That is the final answer for this particular question, as you can see, using the two methods over here. Now this is a simpler substitution, and this is using the idea of partial fractions that we have been seeing in this exercise. We have used partial fractions in between over here. This is simple substitution, and we have only used substitution in this particular method. So such questions will be easier with the help of this approach as we have discussed over here. You can take a look at this, I'll get a side, and that's the complete solution of this 16th question as you have seen.